Hello, everybody, and welcome. It is day 6 of Advent of Code 2022 in Kotlin, and I, of course, want to thank everyone who's stuck around so far. Good to still have you here. Gonna have another very chill evening of talking a little bit about today's problem, and just kind of enjoy the problem solving. Now, today's cup, in case you're interested, is a cup from my university, the Technical University of Munich. I think it's gonna give you a lot of fun today, because if I spin my my spoon inside it, unfortunately it is shaped like an octagon, which means you're probably gonna hear a couple of noises. I apologize in advance, but I am drinking a tea that tastes suspiciously like apple pie, so I won't be able to stop myself from refilling this during the session. I'm sorry about that. Well, if you are in the chat as usual, make sure that you say hello, give us a little wave, or I'm not really sure if I even want to ask for today how hard you found this particular problem. I'm having a feeling, getting kind of a rough idea of what y'all are feeling about this. Yeah. The hat is fully charged, so we can do a nice little reading, and I'll take bets on whether reading the problem statement or explaining the solution is gonna be faster. So we'll see. We'll have here. All right, yeah. There seems to be a general consensus. I wonder if I can show multiple of these at the same time. No, I can't. But yeah, the general consensus seems to be everything was so easy. And Olaf even asks, "Why did I even get up that early?" Well, the answer, of course, is to take part and try to compete for one of the top spots in one of our leaderboards. There's 6 of them now, which is crazy to me. That means there's over 1,000 people participating just in the Advent of Code in Kotlin campaign, which, yeah, isn't that amazing? It's really cool to see the community come together like this and have just an enjoyable time. The Kotlin libraries were really well suited today, says Jürgen. And I think we're gonna see later why that certainly is the case. And to do a little bit of a spoiler, we're also gonna see why that's probably not even the optimal way of solving this problem. Because today we got a lot of... I went deep into the benchmark box, and we looked at a bunch of different ways of solving this one. So, yeah, I would definitely be excited about that part. Before, however, we even move on to day 6, we have some unresolved business. Because if you remember, yesterday I read out a message from one of our participants, Olaf, who said he was finally so glad to see a problem, day 5 with supply stacks, to be so nicely visualizable. And indeed, he provided me with this visualization. So I'm just going to pull that one up on stream right now, and we can take a little look. So as a reminder, this one was all about having stacks of crates of different sizes, and trying to figure out what, after all the moves, what the top crates were. So Olaf has built a little visualization for us, and I'm just gonna play this one for us, so you can see how it takes the individual crates. You can see that this uses the second version, or part 2 solution of the problem, and how after executing everything, it generates the final word for Olaf's solution. That's the crate mover 9001. Gonna run this one just one more time to see that crane really do all the work. I'm a big fan. So Olaf actually built this one using a custom-made GUI library that he built for himself, based on a header-only, really simple library, which had the goal of making small visualizations from, the last century, from like these retro computing type graphics, shapes, letters, all that kind of stuff, really easy. And that's exactly what he's kind of used for this one. And his code is also on GitHub. I can probably pull up that GitHub account as well if I was better prepared. Let me just give me 2 seconds here. And we'll take a look at that one. But isn't that nice? In the meantime, I can also show you the first visualization that he sent me, which was a little bit more abstract before it was slightly improved, just so that we can see a before and after. So with this one, you can still see the crates moving, but it doesn't have the nice little animated crane. And of course, since there's no letters in there, it's much less tangible, but still kind of nice. Reminds me of an audio visualizer of some sort. So the all of this is in Olaf's repository, the add-on of code Kotlin 2022. I can also link that one in the stream, so if you want to send some love to Olaf for the things that he's done, you can give that repository a star. Wouldn't that be exciting? All right. We're gonna do a quick check-in with our latest leaderboard and see that there's already 8 people in here, so there's around 190 slots still left. As usual, you can find all the information about the leaderboards in our blog post. If you haven't joined one yet, then make sure you do, because there's going to be exclusive swag that you can win only during this campaign. Okay, well, enough of that. I think it's time for us to introduce today's guest and start talking a little bit about day 6, because that's what we're all here for. So, welcome to the stream, my wonderful colleague, Anton Ahipov. Hi, Anton.
Hi. Hello, everybody. Nice to be here.
How are you doing today?
It was a long day. I was trying to put myself to work after solving today's problem, but it was so nice and simple. I decided to take another one and then another one, and I got nothing done for the real job, but I was playing with Advent of Code today.
Working your way backwards?
Yeah.
I see. Yeah. Advent of Code tends to kind of do that. You get these nice, well-defined problems where everything is clear and everything's set out, and you even get like little stars at the end, right? It's just cozy.
It is. I find it actually like there are some open edges in the tasks. Like usually, if especially with parsing how the problem is presented. For instance, the yesterday's task, when you parse the input, there are some open questions like how much data you actually would get. Like, is it the infinite number of stacks that might be, given to you, or infinite stream of commands, and so on. Like, so there is always like where do you stop? Where do you stop generifying your solution? Is it good enough? Is it generic enough? Or is it like, do I want to push the limits?
Yeah, I especially yesterday, one of the things that made me kind of pause for a second was also like the problem. It showed you that there's 9 9 stacks, I think, by default.
Yeah.
I'm not sure if that's for everyone, but I think at least for me it was 9 of them. And I immediately checked, like, I was like, okay, let's see here, like, let's look through all these numbers and see if there's a number that's larger than 9. Because I was like, that's gonna be the classic curveball, is another stack just materializing, because, like, it was just empty at the beginning, right? That could be. So yeah, these kind of, like, little things and little quirks that you have to think about, yeah, they can certainly throw you a curveball.
Right.
Yeah. By the way, this is also, by the way, a great reminder, just really quickly, because I just loaded this page, that Advent of Code is sponsored by JetBrains and at least in our heart, by all of us in the Kotlin team. Yeah, we of course support Advent of Code as well. And if you want to give back to this wonderful campaign, make sure you also consider getting Advent of Code Plus. It's a pay what you want type deal. It gets you this nice little badge, so you can feel even better about yourself in the leaderboard. Okay, cool. So I take it you didn't wake up at 6 a.m. for this one, did you?
A bit later, but not because of the challenge, but because I have to take my kids to kindergarten and school. So no, I didn't wake up that early.
Yeah, fair enough. But I've already been up for 12 hours at this point. So yeah, it's probably better to maybe like have a scheduled nap time or something in the middle. I don't know. Okay. Well, let me put on my reading hat for today. You know how this goes. And I'm going to give us a little bit of a dramatic reading of what our input is, and then we'll start discussing. Again, we're taking the nice route, or we're just gonna check whether it's gonna take us longer to solve this or to read all the input. Jonah asks, if you joined the Advent of Code with Google instead of GitHub, can you still participate for the prizes? Yes, you can. You can just send me if you are on the Kotlin Lang Slack, you can just send me a DM. Sorry, that is slackchats.kotlinlang.org. Just send me a message. It's Sebastian Eichner with a little JB icon. And just let me know that you're using a different type of repository. I'll make sure I'll add you to the list. So yeah, if you're not willing to create a GitHub, that's one way to do this. But also, go to the Slack chats anyway. The Advent of Code channel has a wonderful community of people organizing and kind of discussing, suggesting improvements, like filing down their code until it's the very best it can be, which I think is very exciting. Okay, enough on that tangent. Gonna put on the hat. It's story time. Day 6, tuning trouble. The preparations are finally complete. You and the elves leave camp on foot and begin to make your way toward the Star Fruit Grove. As you move through the dense undergrowth, one of the elves gives you a handheld device. He says that it has many fancy features, but the most important one to set up right now is the communication system. However, because he's heard you have significant experience dealing with signal-based systems, these of course all being references to previous Advent of Code, he's convinced the other elves that it would be okay to give you their one malfunctioning device. Surely you'll have no problem fixing it. As if inspired by comedic timing, the device emits a few colorful sparks. As if inspired by... To be able to communicate with the elves, the device needs to the device needs to lock on their signal. The signal is a series of seemingly random characters that the device receives one at a time. To fix the communication system, you need to add a subroutine to the device that detects a start of packet marker in the data stream. In the protocol being used by the elves, The start of a packet is indicated by a sequence of 4 characters that are all different. The device will send your subroutine a data stream buffer, your puzzle input. Your subroutine needs to identify the first position where the 4 most recently received characters were all different. Specifically, it needs to report the number of characters from the beginning of the buffer to the end of the first such 4-character marker. For example, suppose you receive the following data stream buffer. Just have a look at that one. After the first 3 characters, M, J, and Q have been received, there haven't been enough characters received yet to find the marker. The first time a marker could occur is after the 4th character is received, making the most recent characters MJQJ. Because J is repeated, this isn't a marker. The first time a marker does appear, or appears, is after the 7th character arrives. Once it does, the last 4 characters received are J, P, Q, and M. J, P, Q, and M. Which are all different. In this case, your subroutine should report the value 7 because the first start of packet marker is complete after 7 characters have been processed. Here's a few more examples with the first marker after character 5, 6, 10, and 11. The question now is, how many characters need to be processed before the first start of packet marker is detected? All right, so we have our puzzle laid out for us. Anton, where did your mind go when you read this one?
Well, I usually prefer to start solving this kind of things in a very naive way. Like, obviously, we need to parse the file. We get a list of lines, then we have to iterate those lines. So I always go with the iteration with no fancy stream operations or anything like that. And immediately when I see this kind of a task where you get like a string or a list and you have to move in the windows, like you have these chunks that are sliding over the collection of elements, then this is immediately you will think of either chunked if you need that one or windowed function from the standard library. In this case, it was kind of obvious immediately before I even started programming this task.
Okay. Yeah, I think a lot of people's mind went to that pretty directly. So let's see what that looks like in code. I have a bunch of different implementations here, but your code is right here. And I think you're also logged into code with me, so you can even mark some code to make sure it's highlighted properly
Let me
on stream.
see.
Yeah, look at that.
Yeah.
Delightful.
Yeah, it works. So yeah, this function here, solve naively, that was my first implementation when I basically started just, writing the code. Hey, I need this loop here. I'm going to iterate over collection of elements and so on. But obviously the first thing was, okay, I need to chunk the input with the window function. And that's going to be the size of the window that is I'm going to use as a parameter for the function, right? So okay, I'm getting this list of strings where I have 4 characters. Basically, that's the window size in the first part of the task, and then I would just iterate over the list of strings, and I have to find the condition where that was given in the task, right? Once all the elements are unique, then I'm there. Then basically it's solved, right? So how do I check for uniqueness? Well, if I put everything into set and suddenly the size of the set is less than the window size, actually we could compare not with the window count here, but with window size instead. That would be maybe even slightly faster. And because like the first, when we start using the window function, it actually skips the first characters. Like in the beginning, we need to add this window size to the final result. right?
Mm-hmm.
That's a very naive way of implementing this with iteration. And when I'm done with this kind of approach, then I start optimizing. If I have too many loops, let's say I have nested loops, then I start thinking, okay, maybe I want to get rid of them.
Mm-hmm.
Maybe I would. Usually, the very first thing I do, I go to the for loop and I hit Alt Enter. And if it suggests me to change or to replace it with for each or for each with index or something like that, right? Depends on the complexity of the code. And then I thought, okay, if I'm actually just looking for the first appearance of that condition, that all the elements are, unique in this window that I'm parsing, then basically I just need an index of in that list of strings of that specific string where all the elements are unique. That's why I actually thought, okay, I'm gonna take this input and just use index of for that string. And when I started writing this, I realized if I'm transforming the collections, why do I need to transform the collection into string? I can immediately transform it into a Boolean instead. So I'm transforming the string immediately to the Boolean. Well, actually, in the beginning, it was just this condition written out, not the extension function, of course.
Mm-hmm.
It was like this. Actually, yeah. Well, you understand, anyways.
Yes.
And then the first value that is true, that's my index that I'm interested in, and all I'm left to do is to add the window size to the result. And that's it.
Okay.
So basically, one-liner.
Yeah, and the other cool thing, of course, is that since you use Windows sequence, all of this is kind of iterated, I guess, lazily, right? Or it's kind of iterated. You iterate the whole call chain on each element before continuing to the next one, which means you don't create, like you did down here, you don't create a large list of elements and then you iterate over it. You create an element, see if it works. If it's true, then that's your index. And if it's not, then you start creating the next window and do your operation on it.
Well, it's always a trade-off. Like if we are dealing with a huge data, maybe this would be the way to go. If we are dealing with chunks of data, with a lot of small or medium-sized chunks of data, maybe Windows sequence would not be a benefit, but we would lose in performance actually then.
Yeah, that's
and
something that's
actually
worth checking out.
and I'm actually cheating with this a little bit, because you see, like in this naive implementation, if I'm not finding the solution, I'm just returning -1.
Yeah.
But here we assume that we always find a solution. Like that's the infinite sequence, like somewhere like in future we are going to get that condition and we're gonna get the what we are looking for. But otherwise index of might return -1 and we add window size and we get very weird result that we actually could check like at the very final stage, that the number we are getting is less than the window size. Then it's strange. But I'm not sure. Maybe it's not the way to check it. So yeah, I wouldn't say that it's a bulletproof solution in this way.
Sure.
Depends what you are looking for, right? If you're trying to do like defensive programming, check for all possible mistakes and so on, then it's probably not the best solution, but it's good enough for solving this simple task, of course.
Oh, certainly. I think this is one that you can come up with quite quickly. Now, in the chat, someone actually mentioned that in Kotlin we do have a function called index of first. which which kind of allows us to merge these two together and get rid of this this true part, I guess, which makes this whole thing even shorter. Now it definitely feels like a one-liner. If we add one here, I can even fit it on the screen. There we go. Look at that. Which is also very elegant. I like that. Thank you, Cropeb or Cropeby. Nice. Okay. Yeah, from there we can pretty much switch directly to my solution, which, shocker, is going to look extremely similar. It's just a windowed function, uses index of first, does the same set comparisons. I just decided to hard code the values because I wasn't sure what was going to happen. And that was pretty much it. Before I continue with this explanation, however, let's make sure we understand how this challenge has changed in part 2. It's going to be a very short dramatic reading, so I think the hat still has to charge. So your device's communication system is correctly detecting packets, but still isn't working. It looks like it also needs to look for messages. A start of message marker is just like a start of packet marker, except it consists of 14 distinct characters rather than 4. Here are the first positions of start of message markers for all of the above examples. Then we get a bunch of examples. How many characters need to be processed before the first start of message marker is detected? And again, this one pretty trivial. It's the same exact approach as previously, just with a different number. Now, I saw that you wrote an all unique function which was wrapping essentially the comparison of toSet and count, and comparing it to the length of your input character sequence. Now, after some discussion with a colleague, I actually realized that there's a version of this which is which may be slightly more performant, which is creating the set first and then adding the characters one by one, but making sure that all of them can be added. And the reason why this is slightly more performant is because the moment you add a second character, this terminates, right? Your all predicate stops iterating because it says, okay, if one of them is false, then it's not possible for all of them to be true, so I can just quit. So this is a slightly it's just a slight implementation detail that's not gonna change the world. But yeah, so we could do an all unique.
Depending
right here
on the situation, you might get a good, cut with the performance. It depends on the data that you're parsing and handling.
That's right. And I didn't want to just sit here and guess. So what I did was I wrote 16 different versions of this same little snippet, all with some slight changes, and I benchmarked them. And I wanted to see what kind of the difference is. So I've already benchmarked these ahead of time because benchmarks do take time. So we have them down here. So we can just go through each of these variations and see how the performance changes. Starting with the very basic one, that's just, our baseline. Baseline on my machine, which is part 1 naive, is round about 4,700 operations per second. So you can calculate this 4,750 times a second just on my machine. Now, let's do a quick check on whether this number is reasonable. If I look at part 2, which is harder to compute because the numbers or the sequences that I need to find are longer, this one is much slower. This one's only 1,000, around about 1,100 operations per second. So yeah, these are just the naive ones. And then I started changing things. And I guess since we have a bit of a stream delay, I think, Anton, you need to be a stand-in for our crowd here, and you need to help me guess whether things are gonna get faster or slower. So in the first one, we used the regular windowed function, which means we allocate all the windows first and then do our checks. We've contemplated whether windowed sequence might be faster. So what's your thought? Do you think this one's going to be slightly faster, slightly slower?
I think it will be slightly faster for the first case and a little bit slower for the second case. But
Okay.
It might be vice versa, but my kind of intuitive thinking right now, which might be wrong totally, saying that in first case it will be faster, in the second one it will be slower.
Yeah. Okay, so reminder, this is operations per second, so bigger numbers are better. If we compare the naive version to the sequence version, we will see that the sequence version is indeed actually better for part 1. You're correct. Let's have a look at part 2 naive. This one was about 1,100. And if we go to sequences, this one is 1,086. This one is actually, well, it's very comparable.
A little bit better, yeah.
Yeah. So worst case, what I'm seeing here, at least for our inputs, is worst case it's the same speed. It might be slightly faster. If you have smaller things, which honestly surprised me, because yeah, generally you would think that on the larger one, maybe you would have a bigger impact for sequences, but doesn't seem to be the case here. And
I think sequences are generally better if you have larger inputs.
Yeah, but surprisingly enough,
not in terms of operations, but in terms of memory and kind of continuity of the program, of the application. If you think about data, like big data world, like if we are processing huge files, then you would go with sequences.
Oh, sure. I mean, especially if you're doing some kind of filtering operation or something where you're finding the first element, then you're definitely gonna on like really, really large data sets, you're probably gonna see it. But here, it's quite comparably. Olaf says the thing that takes up the most time is the set building. That's why the outer code does not matter that much anymore. Interesting.
I like the comment by Aaron about Kotlin.
Last year I didn't go. I'm new to Kotlin, but so far it feels like I'm cheating. Oh, that's a wonderful comment. Yeah, that's the power of a vast standard library. I have a whole talk on this. If you look for Back to the Standard Library, you'll just have me swooning over all the cool functions that are in there. So yeah, I agree.
Yeah, it generally feels like the standard library has been built for advent of code. There are a few things that we might cover, like transposing the lines into columns, for instance, or checking for the unique characters in a set. But otherwise, like so many things you can actually cover with the standard library.
Yeah. So, and don't worry, Olaf, I got you covered as well. There's gonna be we're gonna talk about a lot of different solutions. See the scroll bar here? We still got things to do. So the next thing I wanted to test was the all unique optimization that I said beforehand. We create a mutable set when we call, and then we just see whether we can add all of them, and if we can't add one of them, we end prematurely. I also checked that the default capacity of 16, which is how a mutable set gets initialized in Kotlin by default, that's also enough. I mean, the largest that we're going to look at for part 2 is lists of 14 characters, so we're not going to accidentally allocate or create a set, then make it bigger. We shouldn't see any impact from that in this, is what I'm saying. Okay, so this is the ephemeral set. So, any expectations in comparison to the sequence version? So my expectation would be for it to be faster. while you're thinking, someone asks here, isn't it 1,000 operations per second? So one execution is 1,000th. I can't say that word. 1 millisecond. Yes, that's exactly what that means. This means you can run it like in this case, for example, it means you can run it 5,600 times per second, which is why bigger numbers are better, because that means it takes less time to execute each one.
So the question was which one is faster, whether hash set or mutable.
The question was whether building a hash set, whether building our set step by step and quitting early is going to be faster than just building the whole set.
Slightly faster.
Slightly faster. Let's have a look here. So from part 1 sequence 5,650 to the sequence with the ephemeral set, we're getting 6,800, which, I mean, that's a pretty significant chunk if you ask me. Like that's quite significant.
That shows you never know until you measure.
That is correct. We're gonna see a little bit more about that in just a second as a spoiler here. For part 2, for the larger one, we also see we got 1,100-ish in the beginning, and afterwards we got 2,700. So that's almost 2.5 times as many operations per second, that's quite the improvement just from exiting early. Okay, so that was pretty much a free win just by rewriting things, which is kind of cool. So now I was talking again to my colleague who's doing these challenges in Rust. So he obviously has different performance constraints and looks at things differently. But I was curious because here we're allocating a new set every time, right? In my all unique implementation, this allocates a new set. So I thought, why don't we just create one kind of global set, and then every time we use it, we just clear it, because that means we don't have to allocate new memory every time, right? We're saving us allocations, but we do need to do the clear operation. So, thoughts?
It's interesting because clear operation is not free either.
It certainly is not.
Okay, it will be faster. It will be faster.
You say it will be
faster? I'm just guessing here.
Of course. Here, yeah. That's why we measure, because our intuition is often wrong.
Okay, my bet is 5% faster.
5% faster. Okay, we're gonna compare this one to our ephemeral set here. So for part 1, the ephemeral set was about 6,871 and now with a global set, it's 5,844. It's actually that is somewhat significantly slower for what I would have expected.
Yeah, like 15% slower, something like that.
Yeah. For part 2, if we look at the ephemeral set, 2,700 operations, to the global set, 2,200 operations. Okay, so this is clearly not the way to go. This is not the optimization that we want to go for. So, okay, global set, not that great. Now, one of the other things, we're actually going to do this in a little bit of a different order because we want to pin obvious things against each other. So we used a mutable set the last time, which under the hood, actually we should probably click into that one. Mutable set creates a linked hash set. But we could, of course, also create just a hash set without the links. So the question now is this going to be faster? Because I think this one doesn't preserve insertion order, so maybe there's some secret optimizations under the hood?
I think so.
Yeah, you think so?
Yeah, I think so. It should be faster.
Like 10% faster, a lot faster. What are we thinking?
No, a little bit. Like it will be pretty much the same.
Okay, so let's compare then. Our ephemeral set, which was pretty much our benchmark so far, is 6,871, and our ephemeral hash set, 7,600. So that's significantly better, if you ask me. And that's for part 1. If we look at that again for part 2, the ephemeral set was at 2,752. With a hash set, we're looking at 4,300. That's, I mean, not quite, but you know, that's a significant increase in speed.
That's huge. That's a huge increase.
Which I guess also gives me kind of time to think a little bit whether I really need a mutable set, whether I really need a tree set, or if there's some places in my code sometimes where I could just get a free, a small one, but still a free performance win just by moving to a hash set as a data structure instead of a linked hash set. Huh.
If you have a huge amount of write operations, probably that would be an easy win, right? But if you don't have that many inserts, then maybe you trade it off for some functionality of the link hash set that you might be, taking advantage of.
Yeah, that might be a good point. Olaf asks, is there a reason for the Kotlin sets using linked hash sets? So this is a little bit of speculation on my part, but as far as the thing that linked hash sets do they are guaranteed to preserve the element iteration order. So we want to allow people to add things to a set and then still iterate them using just for loops and stuff in the exact order that they would expect. Hash sets give no such guarantee. So it's kind of a trade-off between convenience for the developer and the expectations that they can have on their code versus the slight bit in improved performance. Okay. Now that we have a different underlying data structure, the question pops up again. If we, instead of allocating a new hash set every time, I'm sorry for jumping around, I just got my shortcuts confused. Instead of allocating, we could just clear this hash set every time, and that's probably gonna impact performance somehow. So having a global hash set. What are we thinking? Does this one do it faster or slower again? I'm pessimistic at this point because I've seen how the mutable set behaves. So I'm thinking this one's also slower.
I have seen so many strange results in the performance. Now I would actually bet that this one is better.
Okay. All right, let's see. We're gonna compare again to the we're gonna compare to the ephemeral set. The ephemeral hash set, and we're gonna compare 7,604 to a global hash set of 9,171. This one's faster. Okay. You were right. It's not intuitive to me, if I'm honest, but you were correct. This one is much faster.
I think that the clear operation on the link hash set is pretty slow.
That might be it. Let's also check whether this still holds true for the second part. We're comparing an ephemeral. We're comparing a ephemeral hash set with 4,343 to a global hash set with 3,627. So this one is
no silver bullet. There is no silver bullet. It always depends on data.
Look at that. For this size, the global hash set or the clear operation is more expensive, apparently, than just allocating a new hash set every single time. Isn't that something? And I want to, but by the way, just so that we're clear here, I tried to apply reasonable amounts of scientific rigor to all of this. So I made sure that there was a warm-up round that got completely ignored, so that the JVM can do some kind of inlining or do some hot spotting here. And then I made sure there were 4 different sets of runs that were then weighed against each other, so that we can get some kind of confidence interval, and it's not just an outlier because I was browsing Slack on the second monitor or something like this. But yeah, this is a surprising result to me as well. But yeah, so we've learned something here, which is don't trust your intuition, whatever, like whenever, just make sure that you measure. And I also
it feels like the intuition works, and then you win 5%, but when it doesn't work, you actually lose much more.
Yeah, that's kind of what it looks like. But there's also another important lesson here, which is we've just been looking at this type of algorithm, right? We've been looking at the algorithm where we create window sequences, we index them, and then we've just been trying to micro-optimize the way on how we can create all of these elements uniquely. Now, there's also other ways of actually solving this problem, and I've had a viewer reach out to me before the show, Alexander Aftrole, who so graciously provided a different kind of solution, which has a different type of runtime complexity. So this one actually solves the problem in O of n, and instead of O of n plus m, which is the length. So m in this case is the length of the list, if I got that one right. And essentially, what's done here by Alexander is that they keep track of a duplicate index map, which maps a character to like when it was seen, and then just iterates and finds the first index where the elements match the predicate. He does a little bit of magic here, which I've looked at intently, but is probably not quite as easy. I'm liking the inline plus operation in between, like inside the comparison. Of course, there's a post increment, so it doesn't necessarily have to be on this line. It's just because we're computing the index here. This is a very, very compact solution. And with this approach, with an approach that has a better runtime complexity, Anton, do you think it's going to be faster?
Let's say it feels like it's really optimized, right? So it doesn't it doesn't allocate more stuff.
There's no allocations really. There's no allocations going on. There's just a single map being created. Sorry. Yep.
I think it will be 2-3 times faster.
Okay. So I think our fastest solution for part 1 was the global hash set with 9,100 operations. That's who we're, or 9,200
operations. It will be 20,000 or something.
Okay, so this is who we're sending in the race. The viewer submission was a cool 45,000. All right, yeah. It's my my thought as well. And by the way, Alexander also said that you could probably, instead of keeping around the whole idea of even having characters, you might want to optimize this one using int arrays, which is going to be even faster because you're going to have to allocate even less things. But yeah, okay, so 45,000. That's pretty speedy. We're gonna also look at the second part. For the second part, the ephemeral hash set I think was our fastest contender with 4,343. Any guesses?
50,000.
Not quite. This time, roundabout 25,000, 24,500, but still very much significantly faster. Which always goes to show me, yeah, you can kind of do your micro optimizations, but if you can come up with a better algorithm that has a better runtime complexity, like in this case, you're definitely gonna get performance wins that are probably a little bit more impactful than the version that we so carefully optimized.
Yeah.
We'll have to see about this one if someone so if someone wants to go the real optimized route, then you might have to give up some conveniences of the Kotlin standard library. But of course, this depends all on what you're trying to get out of add-on of code, right? As always, it's not that the fastest solution wins, it's that the solution wins that makes you learn something and makes you try something new. Okay, so as a little treat on top of this, we had another viewer submission, which was a visualization for this part as well. Now, this is going to be a couple of flashy colors. I'm just going to warn you in advance, but I'm going to be pulling that one off up here, where you can see how the list is traversed step by step. You can kind of see the characters flashing by with a window size of 4, kind of like a tape running under a scanner machine until it finds its final result at the end. So this is some nice little party lights. We'll see if it gets to the end. Maybe it's already looped. There we go. Okay, so very briefly showed it and generated the result. And I guess the version for 14 characters would not look much different. I have a string of fairy lights that are flashing about as intensely as this, which is the reason why I don't have them in the background for this video. Everyone, instead of looking at my face, or more importantly, looking at the code, would just be staring at these fairy lights going completely nuts. Yeah. Okay. Man, we have had our worldview change today, huh? I really have to say, if the answer, in the words of an old professor, if someone asks me, should I use a hash set or a mutable set, or should I allocate it every time, or should I clear it? The answer is, it depends.
As usual, yeah.
As usual. Okay. So yeah, but we have. Sorry?
Depends what you're doing, right?
That's right. So yeah, we have cleared day 6. We are one step closer towards saving Christmas, which is great. And yeah, there's going to be more challenges unlocking tomorrow. Do you think you're gonna have another look at them tomorrow, Anton?
I will.
Nice.
Yes, definitely.
Very good. Yeah, I'm going to also be back up on my feet at 6 a.m. sharp to make sure I can solve the next one and bring you a little bit of entertainment just 12 hours later. Because tomorrow we also have another special guest. In fact, they are one of the people who won last year's leaderboard for the Advent of Code in Kotlin challenge. They were all the way at the top of the community leaderboard, and it's Ephemiant. So if you wanna see what a true Kotlin champion does, what kind of code that they write, make sure you tune in tomorrow. It's going to be really exciting. We have a bunch of other guests coming up for the rest of the time. Now, I'm also at a little bit of a crossroads because this whole campaign is supposed to last for 10 days. Now, I have the option, in theory, to do 2 more streams after that, so to cover days 11 and 12. But of course, only if somebody out there is still interested. So if you are interested in that, maybe you could leave like a quick little comment in the stream chat. Maybe also give the video a little bit of a thumbs up or some kind of other engagement, so we're seeing it in the numbers. And if that's the case, I'm gonna go back to all the people behind the stage, playing the music, and making sure that all of these things work. And we'll see if we can do 2 more streams if there is some interest. So yeah. Let's have a look here. Yeah. Mm-hmm.
Did you explain the peeps how does the leaderboard work? Actually, like what solutions win? Like, is it the one who is submitting faster, or is it the one?
Oh yeah, we can go over that one. We can go over that one again. So of course, all the information you can find in our Advent of Code 2022 in Kotlin blog post, which is linked in the description if you are on YouTube. If you are on Twitch, you're gonna have to find it somehow else. I recommend going to blog.jetbrains.com/Kotlin and looking at the topmost thing. Or maybe I can just post this one in both chats. Let me just do that one real quick. Boop. Yeah. And the way that you can get some exclusive Kotlin swag is just by joining our leaderboards and making sure that you have attempted to solve at least 3 of the problems that are in there. We, of course, also need a way to contact you, but that's besides the fact. So not only are we going to have people from the leaderboard who are going to win, so those are going to be like the top people if you want to compete, we are also having the Advent of Code 2022 in Kotlin topic. So if we have a quick peek in here, we can see that there's already 1,255 people who have attempted to solve some Kotlin problems and tagged their repository appropriately. So these folks are all eligible to win a couple of cool Kotlin prizes. Doesn't matter when they submit the solutions. You could be starting right now, and you would still be able to get some of these prizes. Just make sure we have some way of contacting you. Twitter is fine. Email is fine. Mastodon is probably also fine. I don't have a Mastodon account, but I'm sure one of our people does who can contact you. So that's gonna hopefully also work. Yeah. Reminder that it's a really good time and a good idea to join these leaderboards and to join the Advent of Code 2022 in Kotlin topic as well, because you're not going to be able to get any of that swag after the campaign concludes. I'm seeing a bunch of love in the chat here about, yeah, we need all 25 days, sir. I gotta buy Christmas presents at some point. I'm very sorry. Really love the stream. Cover more days. Keep going, especially for the hard problems. Please, please, please. Okay. All right. We'll see what we can do to cover things until day 12. That's the promise. We'll see what we can do is the promise I'm gonna make. If you want to see if we are gonna do the streams, make sure you tune in tomorrow. Probably I'm gonna have updates for you there. Okay, I think we're going to end it on Olaf's wonderful comment. Today really proved that a relatively easy problem can lead to a great live stream. Thank you so much, Olaf. And thank you also for providing the visualizations that we showed on stream earlier. They were really great. If you have any kind of community-created stuff that you would like to see featured on the show, make sure to reach out to me either on Twitter. My Twitter handle is somewhere. Or if you're no longer on that app, you just can talk to me on the Kotlin Lang Slack. Whether those are some fancy solutions, some visualizations, or anything else, I'm very receptive to it all. Okay, well, Anton, we filled an hour talking about.
We made it.
Yeah, exactly. We filled an hour talking about what was essentially 2 lines of code. Isn't that cool?
Yeah, I really liked the list of benchmarks, and so many surprises in there.
Yeah,
this is definitely something to think about when you're trying to micro optimize your program.
That's right. If you want to do the same thing for your own projects, make sure you check out Kotlin X Benchmark, which is the project that I used, and we've also recommended a couple of times. You can use that one if you have any surprising numbers, or you manage to really make some code that is going to outperform everyone else. Benchmark with this, and we'll see. We'll see who can write the fastest code. Who knows? I have a feeling that at least on day 8 it's going to be Roman Elizarov, but we'll see. Okay, great. Well then, Anton, thank you so much for joining me on this performance journey today. Something really special.
Thanks for inviting.
Yeah, and I hope that I'm going to see all of you tomorrow, same time with Ephemiant, where I think we're going to have a great time with whatever comes next. For now, enjoy your evening, afternoon, or whatever time it is, and take care. Bye-bye, everyone.
Have a nice Kotlin.